So I'm going to discuss about beta decay. So now in beta decay, what will happen? In beta decay, a nucleus spontaneously emit an electron. So if the nucleus will emit an electron, if the nucleus will emit an electron, then it is called beta minus decay, right? So if nucleus will emit an electron, it is beta minus decay. And if the nucleus will emit a positron, if the nucleus will emit a positron, then it is called beta plus decay. Okay, so then it is called beta plus decay. Okay, so the common example of beta minus decay is that for beta minus decay, for beta minus decay, I would like to give one example to you. So this is 15 phosphorus 32. Now it will decay to 16 sulfur 32 plus this is electron and this is antineutrino. So now the general form of this beta minus decay is, this is ZXA, and it will decay like this. It will go to Z plus 1 by A and plus electron emission plus this is antineutrino, right? And for and that of the beta plus decay is, and that of beta plus decay is, so this is 11 sodium 22 and this is 10 neon 22 plus positron emission, and this is neutrino. Okay, so now here in this case, this is the positron, and positron having the same mass as that of electron, but the charge is different, right? So this part is neutrino, and this is possibly of the zero mass. So now the half-life of this reaction, this nuclear reaction is this is 14 point T half of this is of 14.3 days. This is 14.3 days, and the half-life of this is T half for this reaction is, this is 2.6 years. Okay, so now both of these reactions will follow the exponential form of decay law, and that is equal to n is equal to n0 e की minus lambda t, right? So इसका मतलब क्या हुआ? We have to understand the physical meaning of this form of equation, exponential form of decay law. This means that which of the nucleus undergoes decay we can never predict. The physical meaning of this law is that which ever nuclei will decay we cannot predict. हम ये नहीं बता सकते कि कौन सा न्यूक्लियाई जो है वो डिके करेगा और कौन सा सर्वाइव करेगा. Okay, so now here this as the questions to this neutrino, this neutrino is a very small part. It's a neutral particle, and it's of possibly of zero mass, and it is very difficult to detect this particle. So it can penetrate the large mass of matter, and even I can say earth, without any interaction. So right, so now in both beta minus and beta plus decay, in both beta minus and beta plus decay, in both now see here, in both beta minus and beta plus decay, in both beta minus and beta plus decay, the mass number will remain the same. So mass number A mass number. This will not change. The mass number will not change. But in case of beta minus decay, the atomic number will increase by 1. Okay. But in case of beta plus decay, the atomic number will decrease by 1. Okay. So this is the point of difference between the beta minus and beta plus decay. Right. So now what is the basic application of these two, beta minus and beta plus decay? The basic nuclear process underlying beta minus decay is the conversion of neutron to proton. See here, conversion of neutron to proton. Conversion of neutron to proton. Right? So when neutron will decay to proton, it will emit the electron as well as antineutrino, right? So this is when a free neutron will convert into proton, it will emit the electron and antineutrino, right? So in this case, the Q value of the reaction is greater than 0 because the mass of the neutron is greater than mass of the proton, right? While for the beta plus decay, while for beta plus decay, while for beta plus decay, it is the conversion of proton into neutron. It is the conversion of proton into neutron. Conversion of proton into neutron. So when proton will convert to neutron, right? So it will emit the positron with the emission of neutrino. So now see carefully, it is very interesting now to understand that the free neutron decay to proton. A free neutron will decay to proton in a spontaneous way. Why? Because the Q value of the reaction is positive. If the Q value of the reaction is positive, then the process is spontaneous. But now here in this case, now इस case में देखिए Q value of the reaction is negative. I mean, if the Q value of the reaction is negative, the process is non-spontaneous. So why the Q value of the reaction is negative? Because it is the mass of the reactant is less than the mass of the product. So here in the reactant, it is the proton, and here in the product, it's a neutron. So mass of the proton is less than mass of the neutron, right? So this process is only possible inside the nucleus. So conversion of proton, conversion of proton into neutron is possible inside the conversion of the proton into neutron is possible inside the nucleus. Thank you.